What I'm going to do now is to show you how to do all the estimations in R. R is an open source. It deals with packages. It deals with packages. And there are quite a number of packages you'll be dealing. When you open the R for the first time, it's blank and it's empty. The information will be typed in the window called the command window at the top here. That's why you see the cursor is blinking there. Okay. So the results will be shown at the bottom down here in the console. So take note of that. Now, the first thing to do is to import your data from Excel or wherever it is to R. You can actually type the data also into R. Okay. You can type it directly into R, or you can just import. Okay. And you can even copy and use a clipboard approach to showcase the results. So I'll be going through this. So first, what I want us to do is to have our data set. Okay. The data set we have been dealing with is here. So I'm going to show you the data set. So this is a data set. It's a data of 5 DMUs. There are 2 inputs, 1 output, which has been normalized. And each of the inputs have got their prices, which are W1 and W2. We'll not deal with this today. Okay. Now, what do you do? The first thing you do is to send this data to R. So you highlight the information in the data set. You do Control-C to copy, or you can right-click and choose copy. Either one is fine. Then you go to your R Studio. So go and open your R Studio. This is the R Studio. You see the cursor is blinking at number 1. You don't type R Studio. You don't just copy and come and paste here. No, that is a wrong way of working. There is a very smart way of working, and that's what we're about to do. Okay. Now, you have to just get used to the R. We'll be talking a lot about matrices, rows and columns. We're talking about vectors, but most of the time we'll be dealing with a data frame. We're dealing with a data frame. Okay. So the first thing we are going to do is to give the name of the data we have copied from Excel to R. So let's call the data FAM1. FAM1. Where the FAM1 is just the name for short name for family. Then you write equal to, use the clipboard command. So you type read.delim into brackets, you bring your double apostrophe and type in the clipboard. Clipboard. Spellings are important. So this command, in order to give an instruction, you bring a hash sign. Then just give an instruction to indicate what a command means. So we say that this exports data from Excel to R. Okay, so you're exporting the data from Excel to R. And like I told you, you have already copied the data. You have already done that. You've copied the data. So once you type this command, with the cursor blinking anywhere in command number 1, just do Control-Enter, or you will see at the top, you will see run, and click run. The moment you click run, whatever was copied onto the clipboard will be run. And for you to know that the data has been run, you look down in the console at the bottom. You see that it's been written blue with no error in red. It's been written blue with no error in red, which means that the data has been loaded. For you to know that the data has been loaded, just highlight just the name of the data, FAM1. Highlight only that one and run, or click Control-Enter. Then look down there in the console, down here. You see down there, the data is loaded just as you wanted it to load it. So now the data is in the memory of R now. Okay. What is the next thing to do? The data has been loaded. Well, for us, we are going to do something with this data, which is interesting. You see, this data is called farm1. But and when you look down there in the console, the names of the data are 1, 2, 3, 4. But we want the names, instead of 1, 2, 3, 4, 5, we want the DMU names to be the names of the data. Just as it was in Excel, technically. So we want the names of the DMU. So we want DMU1 to replace 1. We want DMU2 to replace 2. We want the DMU names to stand for the column names. So we'll type a command called farm. Just type farm. So we are renaming it and say that farm is equal to farm1. Okay. But use that box bracket. Okay, that box bracket, this one. Okay. Then you use that box bracket, and then after that, you indicate a comma. Let me write it for you. Indicate a comma and then write -1. Okay. What does this mean? What you are trying to say is that you are telling R to convert the column 1. And of course, the column 1 is the name of the DMU. So you are telling R to convert the column 1, which is the name of the DMU in that data frame, into the row names. And then you should relabel the new data frame as farm. Okay, you should relabel the new data frame as farm. So it's very important to be able to understand it. I don't want to write the whole of the instruction I said, because I know you're smart. You get what I mean. So that's what we'll do. So let's run that. Once the cursor is bringing the Control Enter to run. And for you to know how it looks like, we'll come back to how it looks like. It will look like the same thing because we have now indicated the row name. But just have a look at how it looks like. This is how it looks like now. You see, the name of the DMU is no longer there. So now we are going to affix it. Okay. So in our next command, we are going to affix it. So in our next command, we're going to type something like the row names. Okay, the row names of farm. So now we want the row names of farm, not the farm 1. The row names of the farm, the one you don't see the DMU names. The row names of farm should be the farm 1. Okay, but it should be renamed. Okay, so the row names of farm should be equal to farm 1, and then you bring your box bracket that you had before, and then do 1. Okay, so we are now renaming, and now we are saying that the first column now, which is 1, 2, 3, 4, should now be the names. The first column of the farm should go and pick the farm 1 first column name and use it for that. It's a beautiful command. Okay. So this is just a renaming of the data frame. So I'll just type something like renaming the new data frame called farm. So that is what you've got there. Now, how do you see how it is? Now, let's go and run this. Okay, so highlight this one and just run, and you see that it has now shown you the new name. So now when you go and rewrite and run the farm, it will not give you what it gave you before. It will not give you what you have here before because you have renamed it. So let's run the farm again and watch. You see, now the DMU are replacing the names. No longer just 1, 2, 3, but the DMU1, DMU2, DMU. That is how we have renamed it. Why do we do that? Why do we go through this trouble? We're going through this trouble because we just are going to draw these things and we want it to look good. Okay, the next thing is to C-bind. Use a C-bind to identify the inputs in the data set. Okay, and so from now on, we are going to be dealing with a farm data set. So I call X, all the inputs, you're going to call them X. So X should be equal to C-bind. C-bind. And what are we C-binding? Well, we are C-binding the x's. One of the x's is x1, the other is x2. And where are they? They are located inside a farm. So you type farm $x1, okay, comma. They do farm $x2. You see, it even comes. Now, what this means is that we want to column bind the x1 and the x2 into one thing called x. Okay. So that is just the C-bind function. Okay. The dollar is used here to separate the data frame's name from the variable's name, because the data frame's name that you see here is farm. The variable's name is x1. So you want to use that to separate that. All right. So let's run this. And of course, if you want to look at how it is in the console at the bottom, just highlight the X. And then you see the input. So now it has become one matrix. Okay. You can do the same thing with a Y. Okay. You can column bind the Y. So all Y, now here we have only one Y, but if Y was plenty, all Y should be column binded. Okay. And then you use the same thing, farm $, then you write Y because that was the name of the variable. Okay, so once you've done this, you run that as well. Okay. Now we are going to rename the x1 input, because this is for purposes of drawing. So let's call the x1, okay, let's call it the first input. Okay. You're going to rename it as the first input. So farm into the bracket, not a curly bracket, but a bracket, the square bracket. Okay. Then you do column, comma C. So we want to rename it. And then we use this command to call it x1. So what we are doing is that we are going to label our x1 as x1, for purposes of drawing. Okay, just doing that. And then I'm going to do the same thing for the x2. As for the x2, I don't want to even write. I want to just copy and paste. Okay. And then change the x1 to x2 and change the x1 to x2. So this is just to indicate that in the purpose of our drawing, we want this to be done. So we are done. We have conditioned our table nicely. Now we are going to, let me run the x1 as well. We are going to, so all of them, when you do it, you have to run them. We are going to our R and invoke the benchmarking package. The benchmarking package was developed by Bogatev and Otto. Okay. And the two of them have developed that. So if you don't have it and you're installing it for the first time, go to packages and type install and type the name benchmarking. If you have the internet running, it will start showing benchmarking. Once it shows, you click install and it will be installed nicely. I have installed it. So all I have to do is to invoke it. How do you invoke it? Just type library benchmarking. Okay, library into brackets, benchmarking. See, when you start typing and it's there, it will start showing. And normally it gives you a bit of instruction on what it does. Okay, and it tells you that it models estimations and efficiency. Benchmarking package contains methods to estimate technologies and measure efficiencies using DEA and SFA. It has a lot of features. So that's it. Once you do that, run it, run the benchmarking, and you see at the bottom that it has been loaded. Do not worry yourself with any red information. It's been loaded nicely. Other than that, if you don't have any of the previous packages it is talking about, you just have to look for them, search for them, and then install them. All right, so benchmarking is loaded. How do we now proceed? The first thing we want to do is to plot the efficiency. Okay, so I'm going to plot the efficiency. So I can give it a command and call it instructions called plot the efficiency graph. Now, what command are we going to use to do the plot? Well, we use the word plot. And then since we have already given the x1 and the x2, we'll write, we are going to plot x1 and x2. So this is an input-oriented graph. Remember, we are letting the R do the plotting for us. Okay. We want this plot to have a color. So you do a comma and then do color. Color is COL in R. And then want to give it a color called blue. So bring a double apostrophe first before you write your blue. Okay. So that is the color I want to give. Then want to also give a line weight. So line weight is LWD. LWD, line weight. That is the thickness of the line. Let's make it equal to 5. That means that the line is very thick. You can make it 1, 2, anything. You can be changing some of this. And then the pitch, the position. Okay. The position. You can talk about the position and then the symbol type. What symbol are we going to use to do the plotting? Okay. So that symbol type, it has a name. It is called PCH. So do PCH. And the symbol type, you want to give it a symbol type of 8. That means it's very, very thick star. Okay. That is a symbol type. And then the sex. The sex is something you can give, and the sex is kind of a location of where you want the symbol to be. So it's the size of the symbol. If it is a text, it's actually the size of the text. Okay. The size. And we want to give it 1. And then you can add other things. For example, you want the names of the firms. So you write text. And then you shall use true. Yes, you want the names of the firm. You shall do that. And finally, let's get a title. Title is main. And let's give the title of the thing to be title main to be double of, let's call it DEA isoquant. Okay. So now we've been able to plot, show everything. Now we're going to run this thing and you see the plot on the bottom right of the screen. Okay. You got to be doing this alongside with me. You got to do this because this is what you would do. Once you now run it, there you go. The plots are showing nicely on the right. Now you can see that the size of the symbol is too big, the 8. So I can change the 8 and make it 4. Let's just watch how it looks and run it again. You see now it's looking a bit cool when I change the plot size, the PCH. You can change any of them. The line weight is 5. You can make it like any other number and then you work it. So that is a plot. So this is a scatter plot of the data set. What is the next thing? The next thing is to draw the isoquant. Draw the isoquant. And the command to do that is called DEA.plot. Okay. You see, we have the isoquant here and you have another one, but I want to change and use some other things. If I use the isoquant here, okay, it will give me, but I want to make some additions. So DEA.plot. So in that one, you have to specify your input, and then the inputs are X1 and X2, you specify that. You also specify the orientation. So you do orientation, check your spellings carefully. What orientation are we dealing with? We are dealing with input orientation. And so there are ways you write it. Input orientation, you put it in double apostrophe and write IN for input. If it is output orientation, it is out, OWT. And how do you know these things? When you go to the help of your R, and then you choose DEA or you choose benchmarking. Okay. Let's say you go to the home, and then you find a topic called benchmarking. You type benchmarking, which is a software that you are looking for. Okay. You can type that in the search here. It will pull out the benchmark. That's the bottom one here. And then So this one gives you benchmarking tables. Okay. So let's go to, I have done some benchmarkings and things. So it's going to give me all that I need. So once you do that, under the benchmarking, you now select, of course, this will give you all the information you need on benchmarking. But we are looking for the orientation. So you look for the DEA in the list. The DEA. And then when you get to the DEA, you scroll down and it will tell you all that is there. So you see that the orientation is here. Input orientation is IN or 1. Output orientation is out or 2. And then graph efficiency is 3. And then if you are doing directional distance function and you are doing input output orientation or non-orientation, you can do that. So all of these help information out there. After the input orientation, after the orientation, select the returns to scale. So you do a comma and type RTS. There's no need to bring spaces in between them. RTS is returns to scale. And in fact, right here at the help section, when you go up, you will know the different kinds of returns to scale they are dealing with. Okay. You see it there. That's what RTS, that's it there. Okay. And then 0 is free disposal hall, 1 is VRS, 2 is DRS. So we are doing it with a variable returns to scale. So you type 1 or you type VRS. Okay. And yeah, in fact, this one, whether it's VRS or CRS, it won't make any big difference. But to do that, you need to bring the apostrophe before you type the VRS. And then you step out, you bring your comma, and then again, you want the line width. Okay, so I can change the line width. The previous ones, I'm going to use 4 to bring a comma. You also have to bring the sex. Remember the symbol that you want to use. I still want to use 1. Okay. Let me use a bigger one. Let's say 2 might be too big. If you know what it is, you know what it is. Okay. And then you will set up the color of the isochron. Remember, we are done with the isochron here. Okay. So the color, I just want to use equal to sign for the color. So color, COL equals to, and I want to use red for the color. Okay, I want to use red for the color. And then the title of the frontier. Okay. You can use the same name that you had before. I'm just going to use the same name by copying it. So you do comma before you write, else you make a mistake. All right. So we're going to plot the graph. Watch on the right there. There you go. Okay. So we've been able to get the DEA isochron nicely there in the graph on the right. Now we plotted the scatter plot. We've now drawn the DEA. Now we have to superimpose the text, the names of the text. So let's write text. And what we are going to do is that we are going to give a text to them because as it stands, the DMUs don't have names. So let's call it X1 and X2 graph. Okay. We want the text, and the text, we want it to use the names of the rows. You remember the row names? The row names of the fund, that is up here in command number 3. So we want him to use the names of the DMU to represent the graph. So we do that there, you do a comma. Then for the CEX, which is a sex, okay, we indicate how we want it to be. I want to use 0.6. The position, okay, there are several positions, I'm telling you. Okay. The position of the text relative to the location. If you choose 1, it means it's below. And I remember if you choose 3, it's above. Okay. Which text should we use? Which text should we use? So I want to just use a text like position like 3 below. So I want the thing to be below. Because if they're on the right, they will eat into the frontier, as you can see. So for position, so let's do POS, position, and let's use 3 to indicate that we want the thing to be below. And then finally, the color. The color of the text. We want it to be blue. So let's do blue. So let's run this. Okay. All of this will give us the petty information for the text. There you go. So that has been neatly shown. Okay, each one has a text. We said position should be 3, yeah? And 3 is supposed to be below. Sorry, 3 is above. 3 is above. 3 is above. Okay. 1 is below. 3 is above. 2 is left. 4 is right. Okay. So we've been able to draw it. Now the last thing we need is our radial lines. Radial lines. Okay. This is just for illustrative purposes. You can draw all of these things by your own hand. I'm just showing you how R can do it. So for the radial lines, there are some few things we need to indicate. And this is quite complex. I won't lie to you. It's a bit complex. So I'm not going to go deep into that. I've written the command somewhere. So I'm just going to show it. You can later look at it. But this is a very beautiful command that you use to be able to showcase exactly what you want the lines to be. I'm doing it for input orientation. You can always do it for the output orientation or even an orientation. So you type a command called FOR, okay, I input oriented one lines, you indicate the lines, you indicate the lines for the X1, lines for the X2, and then you indicate whether you want to use dotted, zigzag, or the, okay, that's what we have, the LTY. Okay, whether you want to use dotted or normal. The line width is there, the color is blue, and then we use this one to do the drawing. So you can go through it and then check it later. So that has created my radial lines for each one of them. So now you're sorted. You've been able to do the input-oriented graph for this. And if you have done it very nicely, you are sorted. How you do the drawing is an important thing. Any question on that? You can see that I've not labeled my commands. So it's untitled, so you can always do the labeling. Now that you've done this, you can now go ahead and estimate the scores. So the next thing I want to do is to compute the DEA scores. Okay. So let me give it a title. Let's call it estimating efficiency scores. Because I know that some people, this is all they want, but it's nice to have a glimpse of what is happening before. Okay. So how do you estimate? The first thing you want to do is to estimate the technical efficiency score. All right, the technical efficiency scores. Let's do that. So let's call it T, technical efficiency CRS. That's the name I'm going to it. Okay. And you use a command called DEA into brackets, and then you type your input. Remember, we've represented the input X1 and X2 by X, and then all the outputs have been represented by Y. So we'll use that in the representation. You can indicate your returns to scale. Let me bring my comma first. Indicate your returns to scale and your orientation. The returns to scale is what? It is CRS. So let's do CRS. Then indicate your orientation. Okay. And the orientation, we are using input IN. And then we want to indicate if there's supposed to be some slacks. And again, all of these are in the command, in the help section when I was showing you up here in the help section, you get it all there. So indicate slacks. You want it true or false. I want some true. So if there are some slacks, take that into consideration. So let me just do true for the slides. All right. You can do true like this, or you can do T. So this is going to estimate the technical efficiency score. So let me say compute, this is an instruction. Compute technical efficiency score. Let's run that. Okay, and then let's highlight just the first part to see that the scores are there. And beautifully, the scores are there. A, F, EMU 1, 2, 3, all of them have an efficiency score of 1, except E, except the last one, which is what we had in our result. What about the variable returns? Let's do the variable returns. So I'll just copy the same thing here. Remember, this is a small data set, so variable returns to scale is going to be the same as the VRS, the constant returns. So let's call it TEVRS and change the returns to scales to VRS. Everything else is as it is. So this time I'll call it compute PT. Remember, the variable returns to scale is pure technical efficiency. I ran that, and let's see the results. Like I said, I'm expecting the results to be the same thing. And there you go, you got the same results, okay, because this is not a very big technology. How do you get a scale efficiency? We learned this before. The scale efficiency. The scale efficiency is given by the technical efficiency VRS, CRS. So it is this one up here. This CRS technical efficiency, I have to indicate that it is inside this answer, divided by the same technical efficiency but VRS, okay, which is inside efficiency. So I just have to change the C to VRS. Run that, okay, and then let's see the results. That one to the results is 1, 1, 1, 1, 1, because the VRS score is the same as the CRS score. Okay, so you showed that. And you can indicate to R to tell you the summary of all the results. So let's say summary of the TECRS results. I just want to show the technical efficiency results. So this will give you a summary. Look at that. Look at that at the bottom. It gives you the summary of the efficiencies. It tells you that the technology is input oriented, the number of firms, and then it gives you the mean. And then those that are below 60%, 70%, 3%, and all of that. It also gives you a bit of the descriptive statistics, the minimum, the maximum, the median, the mean, and all of that. You can do the same thing for the VRS as well, if you want the VRS result. And then you can put all your results together. Okay, you can put all your results together. To do that, let's create a data frame. So a data frame, a data.frame. And then the technical efficiency, let's give it a name. Let's call it TE for the technical efficiency. And we want that to be represented by the one that is CRS. Yeah, the one that is CRS. So let's copy this for the CRS. So you put that one in a column. So you write C into bracket, and you write the CRS. Okay. Then you step out of the brackets. Then let's do another one for pure technical efficiency equal to C into bracket. This time, let's do for VRS. So what we are doing is that we are just renaming the CRS and the VRS with the new names. So you do a comma, and then for the scale efficiency, let's call it SE into bracket SE. And let me use that, put it into apostrophe. Equal to C into brackets. And the SE was actually just giving us SE. So we just call it capital SE, because that's what we gave it here. Okay. So let's put it in the table. Let's show the results in the table. There you go. The results are all nicely in the table. You can put it in a proper data frame and then give it some decimals places. You can round it. So let's call this one EF. let's call the whole thing rather EF. EF equals to everything here. Okay. And let's run it. And now let's say that EF must be rounded. So round EF, and then the digits should be 3. Okay. Rounds EF, the digits should be 3. So let's round it and see the results. There you go. So we've been able to get the technical efficiency, the pure technical, and the scale efficiency scores for this. Now you know how to estimate it. Okay. The next time, what we are going to be doing is that we're going to add the others, the peers, and several other things, and create densities and more plots, calculate, and then have a beautiful interpretation of the results together with lambdas and everything. And then we'll have a complete, information. So that is how you get the result. Now you can put these results in the table if you want, but I want to keep it here so that next time we continue, we'll be able to have that of the rest. Okay. All right, any question?